Very well. So let's go over the last example. Find, this example says, well, find the shortest distance from the point from 2 minus to 3 to the plane, to the plane 6x plus 4y minus 3z equals to 2. Okay. So this is our goal, finding the shortest distance. So what's the meaning of that? It means that we have a function, which is the distance function, and we're trying to minimize that function. It means that we try to minimize the distance function. Well, but what is the distance function? Recall. The distance between two points, like x sub 0, y sub 0, z sub 0, and another point like x, y, and z, is denoted by d equals to square root of x minus x sub 0 squared plus y minus y sub 0 squared plus z minus z sub 0 squared. This is what we know from pre-calculus. The distance between 2 points is denoted by d, which is equal to square root of x minus x sub 0 squared plus y minus y sub 0 squared plus z minus z sub 0 squared. Well, okay. I have a function. My goal is to try to minimize this function. Optimization question. It means that I'm trying to find the minimum value for this function. Let us go back to algebra. You have a square root. Square root is in its minimum form if the quantity inside the radical is in its minimum form. Note that this is an important note. A radical is in its minimum form if and only if the quantity inside the radical is in its minimum form. So it means that I don't even have to deal with the square root function. What I need to do, I need to minimize this quantity inside the radical. So we only need to minimize x minus x squared, y minus y sub 0 squared, plus z minus z sub 0 squared as our function. This is our function, f of x, y, and z, which is defined this way. There you go. So x sub 0 is 2, y sub 0 is negative 2, and z sub 0 is 3. So let's identify these. X sub 0, y sub 0, and z sub 0. Very well. So f of x, y, z is equal to x minus 2 squared, y plus 2 squared, plus z minus 3 squared. So this is my function that I try to minimize. But the question here is, well, the method that we learned didn't include z. Can I get rid of z to simplify this function? Of course. We can simplify this function using what? Do I have a relation between x, y, and z? Yes, of course. I have this relation between x, y, and z. I can write z in terms of x and y and plug that in here. Why not? Using 6x plus 4y minus 3z equals to 2. Since 3z is equal to 6x plus 4y minus 2, z is equal to 2x plus 4 over 3y minus 2/3. Plug this into the function to get rid of the third variable. Now we have f of x and y equals to, well, I get x minus 2 squared plus y plus 2 squared plus whatever this z is, you plug that in, 2x plus 4/3 y minus 2/3 minus 3 squared. Very well. Now let us apply step 1, then go to step 2, then go to step 3, and try to find the minimum value. So in step 1, we need to take the partial derivatives. What is f of x? F of x is 2 times x minus 2 plus, here you have to apply the chain rule. We're going to 2 times 2x plus 4/3 y, and here it's going to be negative 11 over 3 times 2. Then we're going to find the partial derivative with respect to y, which is equal to, where this y is 0, this is 2 times y plus 2, and then we're going to apply chain rule, which is 2 times 2x plus 4/3 y minus 11 over 3 times 4/3. In step 2, we're going to set these two equal to 0. Step 2, f of x is equal to 0, and f of y is equal to 0. After solving this, you're going to get x 164 divided by 61, and your y is equal to, let's say, negative 94 over 61. Very well. In step 3, we're going to find the discriminant. To find the discriminant, we need the second derivatives here. Well, this is going to be just 2. And here we get 8 plus 8. So this is the second derivative of the function. Let me write this guy down here for you. So our f of x is equal to 2 times x minus 2 plus 4 times 2x plus 4/3 y minus 11 over 3. And the second derivative with respect to x is going to be 2 plus 8, which is 3. Then here we have f of y, which is equal to 2 times y plus 2 and plus 8 over 3, 2x plus 4/3 y minus 11 over 3. So the second derivative of the function with respect to y is equal to 2 plus 8 over 3 times 2 and times 4/3. Very well. So we're going to have 2 plus 64 over 9. And here we get 18 plus 64 over 9, 82 over 9. Here we go. So my discriminant is 10 times 82 over 9 minus. Now, if I take the second derivative with respect to y, I'm going to have 16 over 3. 16 over 3. 16 over 3 to the second power. Very well. So as you can see, the discriminant is positive, and then your second derivative is also positive. It means that you're going to get a minimum value. This is what we're looking for, a minimum value. So step 3 and step. Very well. For those of you who are wondering how we got these two x and y, we are using algebra. We're solving a system of linear equations. So here you have 2x minus 4 plus, this is 4, so let me write this down here, it's easier to distribute this. Or since it's going to be equal to 0, we can get rid of those as well. So let's write it this way. We have 2x minus 2 plus 4, 2x plus 4/3 y minus 11 over 3 equal to 0. This is one system of linear equations. And the second one is 2 times y plus 2. And here we get 8/3, 2x plus 4/3 y minus 11 over 3 equal to 0. So we have a system of linear equations. Well, we can simplify the numerator, the first equation, which is x minus 2 plus 2 times 2x plus 4/3 y minus 11 over 3 equal to 0. And then the second one is going to be y plus 2 plus 4/3 times 2x plus 4 over 3y minus 11/3 equals to 0. Well, here you can write x in terms of y or y in terms of x, substitute that here and solve for the missing variable. Solve one of these equations in terms of x or y, then substitute in the second equation. Second system of linear equations that you learned in elementary algebra. So this is how we get x and y. System of linear equations. Now you're wondering what is the minimum value? D is equal to square root of, because our goal was to find the shortest distance, and the distance function is square root. Well, here you have x, which is 164 divided by 61 minus 2 squared plus negative 94 divided by 61 plus 2 squared plus, and here you can just use the formula that you have here, or you can use X and Y, find Z, plug that in, or just write it this way. 2 times X, 164 divided by 61, and plus 4/3 times negative 94 over 61. And then here we have negative 11 over 3 squared. And after doing the calculation, your D is equal to 7 over square root of 61. This is the shortest distance. So let us take a look at the graph together. Here we have, let us add an object. Well, I have, let's see. Three plus 4/3 y, 3x plus 4/3 y minus 2/3. This is my plane. And then let us see if we can visualize the point. So the point is going to be 2, -2, -2, and then the last component is 3. Okay, awesome. So take a look at this. Here you have your point. Now let me just increase the dimension here so we get a better visualization of what's going on. This plane continues, everyone. This plane continues. So here you have your point. And this point, you're interested in finding the distance, the shortest distance between this plane and this point. Okay, so as you saw, we found the shortest distance. If the question says, hey, find the largest distance, you say, since this plane continues on all sides, if I change the dimension, this plane continues on all sides. So how do I find the maximum distance, largest distance? This guy continues. It's nothing like that this plane has fixed dimension. It's not. It's going to continue on all sides. So it's impossible to find the maximum distance between this point and this plane. It just continues, expands on all directions. You can just add more values to the dimension of the plane. And then, as you can see, it just continues expanding. But how do you find the maximum distance? As long as your plane is continuously expanding on all sides in all dimensions, it's impossible to find the maximum distance. You're only able to find the minimum distance.